Artificial Intelligence Natural Language Processing. Overview. Learning objectives. By the end of this unit, you will be able to understand the importance of NLP and how it helps machines interpret human language. Identify key stages in the NLP pipeline and the challenges of processing natural language. Recognize real-life applications of NLP, including chatbots, voice assistants, and text analysis tools. Perform text pre-processing using techniques like tokenization, stop word removal, stemming, and lemmatization. Explore NLP workflows using no-code platforms for sentiment analysis and language understanding. Introduction to Natural Language Processing. Natural language processing is the third major domain of artificial intelligence after data and computer vision. It focuses on how computers understand and interact with human language, spoken or written. Whether you are typing a message or asking a voice assistant a question, NLP is working behind the scenes to make sense of your words. NLP combines computer science, AI, and linguistics to help machines understand, interpret, and respond to human languages. NLP uses machine learning and deep learning to turn this unstructured language into something machines can understand and respond to. This means machines can read a news article, translate it, answer your questions, or even summarize it. Features of natural languages. Natural language processing deals with human languages which have several important features that make them challenging for computers to understand and process. Ambiguity. Words and sentences can have multiple meanings depending on the context. For example, the word bank can mean the side of a river or a financial institution. NLP systems must use context to figure out the correct meaning. Variability. People express the same idea in many different ways. For example, to ask about the weather, you might say, "What's the weather today?" or "Will it rain today?" NLP models learn to recognize different expressions with the same meaning. Unstructured data. Human language, whether spoken or written, is unstructured, meaning it doesn't follow a strict format like computer code. This makes it harder for machines to analyze directly without advanced processing. Multilinguality. People speak many languages and dialects. NLP systems must handle multiple languages like Hindi, English, Tamil, and their mixed use in everyday conversation. For example, in India, someone might say, "Mujhe ek taxi chahiye," mixing Hindi and English. Context sensitivity. The meaning of a sentence depends on previous sentences or the situation. For example, "It's cold here" could mean the temperature is low or someone is feeling unfriendly, depending on context. Evolution of language. Languages change over time with new words and slang. NLP systems must be updated continuously to keep up. For example, words like selfie or vlog didn't exist a decade ago, but are now common. Example. When you use Google Voice Assistant feature, NLP understands your spoken words, even if you switch between Hindi and English or use casual phrases. It converts your speech into text accurately despite accents or background noise. Applications of natural language processing. Various real-life applications of NLP. Virtual assistants. Virtual assistants use NLP to understand spoken language and perform tasks, making life easier and more efficient. Example. When you say, "Alexa, play my favorite playlist," Amazon Alexa understands the voice command, processes the request using NLP, and plays the selected music on your device. Alexa recognizes the wake word, Alexa, to activate, and interprets the user's intention accurately. Social media monitoring. NLP analyzes the huge amount of text data generated on social media platforms to understand public opinion, detect trends, and filter harmful content. Example. Twitter uses NLP-based sentiment analysis to track how people feel about a new movie release. It can identify whether tweets are positive, negative, or neutral, helping movie makers and marketers gauge audience reaction in real time. Chatbots use NLP to interpret customer queries and provide quick, automated responses, improving service efficiency. Example. On the Flipkart shopping app, the chatbot can answer questions like "Where is my order?" by understanding the query in natural language and providing real-time order tracking information without human intervention. Smart typing and writing tools. NLP enhances writing tools by correcting grammar, suggesting better phrasing, and predicting next words, boosting writing quality and speed. Example. Grammarly integrates NLP to analyze your text for spelling errors, grammar mistakes, and tone. It suggests corrections and improvements in real time, helping writers produce polished documents effortlessly. Speech-to-text and text-to-speech. These applications convert spoken language into written text and vice versa, enhancing communication and accessibility. Example. Google Docs voice typing allows users to dictate their essays or notes. As you speak, your words are instantly converted into text on the screen, helping people who find typing difficult or want to work hands-free. Machine translation. NLP enables automatic translation of text and speech between languages, breaking communication barriers worldwide. Example. Google Translate can instantly translate a restaurant menu from French to English when you take a picture, helping travelers understand and order food easily in foreign countries. Healthcare applications. NLP helps in interpreting medical records, diagnosing illnesses from patient conversations, and summarizing health data. Example. NLP systems analyze doctors' notes and patient reports to extract key symptoms and possible diagnoses, assisting healthcare professionals in providing faster and more accurate treatment plans. Education and training. NLP supports education by providing language learning assistance, automatic grading, and customized content delivery. Example. Duolingo uses NLP to evaluate learners' pronunciation and grammar when practicing a new language, giving personalized feedback that helps users improve their speaking and writing skills. Smart search engines. NLP improves search accuracy by understanding user intent and predicting search queries, making information retrieval faster and more relevant. Example. Google Search's autocomplete feature suggests search phrases as you type, based on your previous searches and popular queries, helping you find the information you need quickly. Stages of natural language processing. Natural language processing enables computers to understand and interpret human language in a meaningful way. This complex task is done step by step through several key stages. Lexical analysis. This is the first step where the input text is broken down into smaller units called tokens. The system identifies the vocabulary and basic structure of words. Example. In the sentence, "I love pizza," lexical analysis breaks it into tokens. It also identifies each word's base form and meaning in a dictionary-like database called a lexicon. Syntax analysis. At this stage, the system analyzes the grammatical structure of the sentence to understand the relationship between words. It checks if the sentence follows proper syntax rules of the language. Example. For the sentence "She eats an apple," syntax analysis identifies "she" as the subject, "eats" as the verb, and an apple as the object. This helps the system understand who is doing what. Semantic analysis. Semantic analysis deals with the meaning of words and sentences. It interprets the context to understand the actual meaning conveyed, resolving ambiguities like word sense or multiple meanings. Example. The word "bank" can mean a financial institution or the side of a river. Semantic analysis uses context to decide the correct meaning in "he went to the bank to withdraw money." Pragmatic analysis. This stage focuses on understanding the intended meaning behind a sentence based on context, tone, and real-world knowledge. It looks beyond literal meanings to understand what the speaker intends. Example. If someone says, "Can you pass the salt?" in a dining context, pragmatic analysis recognizes it as a polite request rather than a question about ability. Discourse analysis. Discourse analysis looks at larger units of language, such as paragraphs or conversations, to maintain context and coherence. It tracks references and how ideas flow between sentences. Example. In a conversation, if someone says, "John is very smart," "he won the competition," discourse analysis understands that he refers to John. Morphological analysis. This stage studies the structure of words by breaking them into roots, prefixes, and suffixes to understand variations and grammatical functions. Example. The word "unhappiness" is broken into "un," "happy," and "ness," helping the system understand its meaning as the state of not being happy. Logical analysis. Logical analysis involves transforming the natural language input into a formal representation, like logical expressions, making it easier for machines to reason and respond. Example. The sentence "all humans are mortal" can be translated into a logical statement for a reasoning system to deduce conclusions. Chatbots. What is a chatbot? A chatbot is a computer program or application that can interact with humans using natural language either through text or voice. It is designed to simulate a real conversation with users. Chatbots work using rule-based algorithms, machine learning algorithms. Chatbots are used to save time for users, automate tasks, and provide instant help or support. Common use cases of chatbots. E-commerce assistance. Use: helping customers find the right product, track orders, or resolve issues. Example: on Flipkart, a chatbot asks users about the product they are looking for, shows the most relevant results, and even helps with return or refund queries. Customer support. Use: answering frequently asked questions, guiding users through processes, or helping with troubleshooting. Example: Airtel's chatbot helps customers check their balance, recharge their number, or report network issues, all without speaking to a human agent. Booking appointments. Use: allowing users to fix appointments for services like healthcare, salons, or government offices. Example: Practo's chatbot allows users to book doctor appointments based on availability, location, and specialization. Order tracking. Use: giving live updates on the shipping and delivery status of purchased items. Example: Amazon's chatbot shows current location of a package and estimated delivery date. It also helps reschedule deliveries if required. Job screening and recruitment. Use: conducting initial interviews and collecting applicant details automatically. Example: Infosys uses a chatbot to ask basic questions like qualifications, experience, and availability before a recruiter connects with the candidate. Education and training. Use: assisting students with study material, answering subject-related queries, or conducting quizzes. Example: e-learning apps uses the chatbot that helps students choose the right course and answers academic questions. Banking and financial services. Use: helping customers check account balance, perform transactions, or report fraud. Example: SBI Yono chatbot helps customers open accounts, transfer money, and track their last 5 transactions via a chat interface. Weather and travel assistance. Use: providing real-time weather updates, travel tips, or booking tickets. Example: the Make My Trip chatbot helps users book tickets, hotels, and also offers travel suggestions based on user preferences. Feedback and grievance collection. Use: gathering user feedback and handling complaints. Example: Zomato's chatbot automatically handles complaints like missing food items or delayed deliveries and initiates refunds or compensation. Technical support. Use: offering help for tech-related problems like software errors or setup guidance. Example: Dell Support chatbot helps users install drivers, update systems, or solve hardware-related issues with step-by-step instructions. Differences between smart bots and script bots. Script bots are simple, rule-following bots used for limited, repetitive tasks. Smart bots are intelligent, learning systems that provide interactive and human-like responses. Script bots. Smart bots work on predefined rules or scripts. Use machine learning and natural language processing. Respond only to specific keywords or commands. Understand human language and context. Cannot understand the meaning or context of the message. can handle complex and dynamic conversations. Do not learn from user interactions. Learn from user interactions and improve over time. Easy to develop and cost-effective. Require more effort and cost to develop. Useful for simple, repetitive, and specific tasks. Provide a more natural, human-like experience. Limited in functionality and flexibility. Have wider functionality and flexibility. Example: a chatbot that answers fixed questions like, "What are your working hours?" Example: a chatbot that can book your ticket after understanding your travel needs. Concepts of natural language processing, text processing. Natural language processing involves several steps to prepare and analyze human language data so that computers can understand it. Two important steps in text processing are text normalization and bag of words. Text normalization. Text normalization means cleaning and converting text into a standard format. This helps computers handle different forms of the same word or phrase consistently. Key techniques in text normalization. Lowercasing, changing all text to lowercase. Example: removing punctuation, deleting commas, periods, question marks, etc. Example: removing stop words, removing common words that don't add much meaning, like is, the, a. Example: stemming, cutting words to their root form by removing endings. Example: lemmatization, converting words to their base dictionary form, considering the meaning. Example: bag of words. The bag of words model is a simple way to represent text data for computers. It converts text into numbers by counting the frequency of each word, ignoring grammar. It treats a sentence or document as a bag of words, ignoring grammar and word order. It counts how many times each word appears in the text. This count is used to create a numeric vector representing the text. Example: for the sentences: I love tea. I love coffee. The unique words are. This processed data can then be used by machine learning models for tasks like sentiment analysis, spam detection, or chatbot responses. Term frequency and inverse document frequency. When we work with many documents or articles, some words appear a lot in one document but may not be as common in others. Understanding which words are important helps computers understand the meaning of the text. Term frequency. Term frequency tells us how many times a word appears in one document. The more a word appears, the more important it is for that document. Example: in a news article about climate change, the word climate might appear 50 times. This shows it's an important word in that article. Document frequency. Document frequency tells us in how many documents a word appears, no matter how many times it shows up in each document. Example: if you have 10 news articles and the word economy appears in 7 of them, the document frequency of economy is 7. Inverse document frequency. Sometimes, some words appear in almost all documents, but are not important. Words like the, is, or and appear everywhere but don't tell us much. Inverse document frequency helps to reduce the importance of these common words by giving them a low score. Rare or unique words get higher scores. Inverse document frequency is calculated as. Inverse document frequency is equal to total number of documents by number of documents containing the word. Example. Suppose you have 3 articles. Email 1 talks a lot about project deadlines. Email 2 talks about holiday plans. Email 3 mentions project deadlines and holiday plans. The word deadlines appears in 2 out of 3 emails, so its document frequency is 2. The inverse document frequency for deadlines is 3 by 2 is equal to 1.5. This tells the computer that deadlines is important, but not in every email, so it gets a moderate importance score. Natural language processing, use case walkthrough. Natural language processing lets computers understand human language, like speech and text. One common use is sentiment analysis, which finds out if a text shows positive, negative, or neutral feelings. Using real datasets, like product reviews or social media comments, tools like Orange data mining help us perform sentiment analysis without writing code. For example, you can load tweets about a new smartphone and see if people's opinions are mostly positive or negative. Orange uses visual blocks to process text, analyze sentiment, and show results clearly, helping you learn how natural language processing works step by step. Examples of code and no-code natural language processing tools. Code-based tools. Programming languages like Python, with libraries such as Natural Language Toolkit or SPACY, let you write scripts to process text, build models, and analyze language. This requires some coding knowledge but gives more control. No-code tools. Platforms like Orange Data Mining or Google Automated Machine Learning allow you to perform natural language processing tasks through easy drag-and-drop interfaces. You can load data, pre-process it, train models, and get predictions without programming. Example. With Orange, you can connect data input, text pre-processing, and sentiment classification widgets visually to explore natural language processing concepts quickly. Introduction to sentiment analysis. Sentiment analysis is used widely in business, politics, and social media to understand public opinions. Companies analyze customer reviews to improve products. Political analysts track social media to gauge voters' feelings about candidates. Even movie studios monitor audience reactions online to decide marketing strategies. Example. After a new game launches, developers analyze players' tweets and forum posts to see if people like the game or have complaints. This helps them fix issues faster. Natural language processing, through sentiment analysis, helps turn large amounts of text into meaningful insights quickly.